Hello guys, welcome back to Techdose, and in this video we will see the maximum XOR of two numbers in an array. The prerequisite before solving this problem is to watch my video on Trie. If you already know that, then you can proceed with this video. It is from the topic of bit manipulation and this is from our Techdose 100 sheet. This sheet link will be present in the description below. You can go there and check it out. And we will be discussing the most important follow-up problems after having solved this problem. So let's first see the problem statement.
Are you ready to take your programming skills to the next level? Well, you are at the right place. Welcome to our data structures and algorithms live interview training program, Techdose. Get ready to dive deep into the world of efficient coding and problem solving. In Techdose, you will get a solid understanding of key data structures such as array, stack, queue, heap, trees, and along with that, you will also master powerful algorithms based on maths, geometry, graph, and dynamic programming. What sets Techdose apart from other courses is the live interactive format. You won't just be watching the pre-recorded sessions, but you will join me along with other passionate learners in real time where we will be covering the concepts together. Imagine having the opportunity to ask questions, engage in discussion, and collaborate with your fellow learners. It's a supportive community where we all grow together. But it doesn't stop there. We will dive into hands-on coding exercises, solving real-world problems, and you will get to work with the interview assignments that will showcase your newfound expertise. Taking Techdose has already been a game changer for a lot of students and working professionals. It didn't just help them to improve their coding skills, but also boosted their confidence for tackling complex problems. The live interactive sessions make all the difference. Unlock your coding potential by taking the first step forward. Contact us on WhatsApp for more details.
In this problem, it is simply asking about, given an integer array nums, return the maximum result of nums I XOR of nums j. And the constraints are that the maximum number of integers will be 2 into 10 to the power 5, and we already know that since we need to solve this within 1 second, then we need to have the number of computations somewhat less than 10 to the power 8 computations. So you can imagine that our order of n square solution is not going to work. In this case, given an array, we want to pick two integers from this array a and b, both should be different integers, in such a way that the XOR value is maximized. And in this case the answer is 28. Let us look at an example for better understanding. In this case, I have taken three integers 3, 10 and 5. Now our goal is to pick two integers out of this array in such a way that if we XOR them, then we get the maximum value. Now you think about what are the possible pairs which we can form. So we can pair this 3 with 10 and we can pair this 3 with 5. We can pair this 10 with 5. So actually, for the first element you will have n-1 pairs, for the second element you will have n-2 pairs, and so on. For the last element you have 1 pair. So you can just add them up to get the total number of pairs, and that will be order of n square. So this will be the total number of pairs. So if you want to check all possibilities about all combinations of pairs and take the maximum out of it, then you can imagine that the time complexity will be order of n square. In this case, you can see that 3 XOR 10 will be 9, 3 XOR 5 will be 6, and 10 XOR 5 will be 15. So the maximum value is 15, hence the answer is 15. Okay. Now let us look at another example. Like, given a number, how do you find the best possible pair to maximize the XOR value? Now you already must be aware about the XOR property, that 0 XOR 0 and 1 XOR 1 both will be zeros. Otherwise, if you take 0 XOR 1 or 1 XOR 0, then you will get 1 as an answer. So you know from this property that if you want to take a and b, and let's say a is 10, so the 10's representation in binary is 1010. Now, if your goal is to maximize the value of a XOR b, then you write the binary representation of a and you write the binary representation of b. But then you want to find b, hence we don't know yet what will be the value of b. Now what will be the maximum value of a XOR b? If you think about it carefully, then all the set bits, if all the answer bits are set, then this will be the maximum possible value for a XOR b. In this case the answer will be 15. But then how to get to this answer? You can simply use the XOR property and fill out the values. If you fill here 1, will you get 1 here? I don't think so. You will not get it. So you need to fill here 0, so that 1 XOR 0 will be 1. Similarly, if you fill here 0, will you get 1 here? No. You need to fill here 1 in order to get a 1 here. Similarly, you need to fill here 0 and you need to fill here 1. Just refer the XOR property table. So by doing this, you have generated the number b. And what is the weightage? This weightage is 2 to the power 0, 2 to the power 1, 2 to the power 2 and 2 to the power 3. So the value of b will be 5. So if you take XOR of 10 with 5, you will get 15. So this is how, given a number a, if you know what is a, then you can easily find out the value of b to get the maximum XOR of is or b value. Now on similar terms, if we need to do this for a set of numbers in this case is an array of numbers, how to find the pair with the maximum XOR? Now if you think about the naive approach, how we would do this? In the naive approach, we will generate all possible pairs. So for 3, we can pair it up with these 3 items. For 10, we will pair up with 5 and 25. Why are we not pairing 10 with 3? Because 3 with 10 was already paired, so it is actually the same meaning. We can pair this 5 with 25. So by doing this, we have generated all possible pairs, which is order of n square again. And then we can take the maximum out of it to get the answer, right? So how did this approach actually work? This approach works because our goal is to maximize a XOR b. If I assume that I will pick this as a, so if this is picked as a, we will try to pick all the rest of the items b one item after another. So once we have picked a as 3, then we will try to pick b as 10, we will try to pick b as 5, and we will also try to pick b as 25. And then we will XOR this 3 with 10, XOR this 3 with 5 and XOR this 3 with 25 and check it out what is giving me the maximum value. In this case, you will see that if you pick a as 3, then b's answer will be 25. So that the maximum value of a XOR b will be 26 if you fix a to 3. Similarly, once a was fixed to 3, now we will try a fixing to 10. And if you do that, again b will be 25 and the max XOR value will be 19. Similarly, you will be fixing a to 5. And if you fix a to 5, then b will be 25 again. And the max XOR value now will be 28. So out of all these possible combinations, you have to take the maximum XOR value, which is 28. Hence the answer is 28 in this case. Okay. So this was the simple approach, which was order of n square time. So how do we improve the solution? If you go back to the previous page, then what was the most optimal answer if given the value of a and I want to maximize the value of a XOR b? What was the, how did we find the most optimal result for b? Actually, what we can do is we can just take the negation, right? So if we take the negation of these 4 bits, then this will be 0, 1, 0, 1. This will be the most perfect answer and you can just provide a XOR and get all the ones. Like I can put any number, let's say a is 1011. Then what will be the value of b to get the maximum value of a XOR b? You can imagine that if you negate all the bits of a and get 0 1s 00, then you will get all the ones. You will always end up with all the ones, which will be the maximum value of a XOR b. So this is the main intuition for solving this problem. Now, how do we use that intuition? Actually, let's say that we had the same array. Again, I am taking the same array example 3, 10, 5, 25. So if you convert these numbers in the form of binary representation, then this will be the binary representation in terms of 5-bit representation. Now, why did I take 5-bit and why not 4-bit or 6 bits or 32 bits? Actually, I will try to optimize the number of bits I take so that the length of the string is also less. So we will actually be taking the number of bits will be defined by the max number in your array, because the max number will consume the most number of bits. And how do you find what is the number of bits? You can take log base 2 of the max number and add 1 to it to actually get the maximum number of bits or the bit length. So this is how we can find, we can just take the maximum number of the array, apply this formula and get 5 as the result. So we need to convert each of the decimal representation to 5-bit binary string. We will be taking all these in the form of a string. I'm just telling you the technique of how to solve this. So now that we know that, all these numbers are in the form of a string, so we need to insert this. Let's say since we will be searching, like we will be fixing an item and we will be searching for the most optimal result, all the search queries on the strings are better served when you use a trie. We will see why trie is optimal, but let's first insert all these strings in the trie. So we will be inserting from in the left to right format, and once you are done inserting, then you will see this kind of structure, and this is your trie structure. After doing trie insert on all the strings, at the end I have also written the number so that you can also identify what is that exact decimal number which I have inserted. Now in this case as well, what was the array? The array was 3, 10, 5, 25. So 3, 10, 5 and 25. Our goal is again to get the two numbers which will maximize the XOR value. So let's pick this as A, and our goal is to maximize A XOR B. We have picked A equals to 3. So what is the value of 3? It is equals to 00011 in 5-bit representation, right? So what will be the best possible result for B to get the maximum value? You already saw that if you negate all these bits, then it will be 11100. But this number may not be present in your array. It may be present, it may not be present. So if it is not present, then we want to get a number, a different number, which is as close as possible to this optimal answer. And how do we get that? So what we do is, we will be searching for this 11100 from left to right, from the most significant bit, this is the most significant bit, to the least significant bit. Why? Because the most significant bit will have the maximum weightage. Hence we will be going from left to right. So first you search for 1. This is the root node where we start the search in the trie. I already explained this in the trie class. So from here we will be reaching to 1. So 1 is been searched. Let's search for another one. Is there another one? Yes. So we will go to the next one. From here we need to go to the next one as well. But from this one there is no 1. So if there is no pointer to 1, then we will be moving to 0 because we have no other option. Yes, we have reached to 0. So our string till now is 110. The next one expected is 0. So yes, we have another 0. The next one expected is 0, but we do not have a pointer to 0. It is a null pointer actually. So we have a pointer to 1. We will reach to 1. Okay, this is the number which is getting generated. You can save it in the node as well, and you will get 25. So what this means is, when you have fixed A equals to 3, then your B value, the most optimal from this given set of items, is 25. So these are the two items which will give you the maximum XOR value. Okay, and you can easily see that 3 XOR 25 was the maximum, which is 26 when you had fixed A equals to 3. Similarly, you will have to fix A equals to 10. So when you fix A equals to 10, then its representation is 0, 1, 0, 1, 0. What is the most optimal B value? 1, 0, 1, 0, 1. So we need to do it from left to right, from the most significant to least significant, and try to find out this answer. Let's see if it is present. So from here you go to 1. Yes, 1 is done. We need to move to 0, but the 0 pointer is null, so we will move to 1. We need to move to 1 from this. Again, the 1 pointer is null, so we will move to 0. We need to move to 0 from here. Yes, 0 is present. We need to move to 1 from here. Yes, 1 is present. So you end up with 25. So when you take A equals to 10, then your B is equals to 25, and this will give you the max XOR value when you fix A equals to 10. You can see that when you fixed A equals to 10, B was 25 and the XOR value was 19. Similarly, if you repeat it for 5 and 25, you don't need to do for the last item. You just do it for 5. You will end up with, for 5, the answer will be 25, right? So I have already written here, like for A equals to 5, we need to search for 1, 1, 0, 1, 0. If you try searching for it, then you will get 1, 1, 0. From here you do not have a 1, so you will end up with another 0. And then from here you want to move to 0, but you don't have it, so you will end up with this 1. So your answer will be 25. So 5 XOR 25 will give you a XOR value of 28, which will be the maximum. You can see that what is the number of operations you are doing. So first of all, you have to insert all the strings into the trie. So what is the max number of bits? It will be a 32-bit number, and you have n number of such items, like n number of items in the array. So order of n time is expected to build this trie, and once this trie has been built, how many items are there in the array? There are n items. So how many candidates for A will be present? N minus 1 such candidates, because I don't want to take the last item. So if you want to follow this, then simply for each item, let's say for 3, you are trying to traverse for just the negated value, and you are just doing one time traversal on this, right? So maximum 32-bit number will actually have 32 length. So similarly, you will have order of n time complexity for finding out the maximum XOR value. So this is how the trie solution works. In order to apply this solution, you need to know all the operations on trie. So you can watch my video. So the time complexity is order of n. Before looking at the code, I'll give you the follow-up question. So your follow-up question can be finding the minimum XOR of 2 numbers in an array. It is very similar to finding the maximum XOR, but instead of finding for the negated value, you have to search for the exact same value, because you know that if a number 00011 exists, you need to find for another instance of 00011. If it is present, then the minimum XOR value is 0. Otherwise, you have to find the number as close as possible to this number in the similar way, right? So that is how you can solve this problem. And for finding out the pair which will actually maximize or minimize the XOR, we have already solved this in the trie. Like when you had fixed, let's say you had fixed A equals to 5, then you will be searching B by traversing this trie. So whatever number you end up with, you had fixed A here 5 and B will be found by trie traversal. So simply your pair will be A comma B, which is 5 comma 25. So the same piece of code can actually solve the second problem as well. So this is how you solve these two very important follow-up problems. Let us now look at the code walkthrough. In this code, you can see that this is the nums array which is coming, and this is the root node, which is the slash which I had defined in the diagram. This is just my way of initializing the trie. You can have your own way in how you write the trie code. Then actually I have converted all these numbers in the string format based on the maximum number of bits that the maximum element will be having. So this is done here from this piece of code, integer to string, where I will be sending the nums array, and the numbers string array, where all the integers will be converted into their bit format, and the number of bits will be based on the maximum element of the array. So this is that piece of code. Once we are done with this, we will be inserting all the string bit representation in the trie. And after the trie has been built, so this is building the trie code. So build trie. And once this is done, then we will be picking one item after another as the candidate. So let's say nums I is the candidate. This is A. Then we will be searching for B here by searching maximum in the trie. Okay, and once this is done, then simply we have to keep track of what is the max XOR value we saw till now, and we can simply return it. If you want to return the pair as well, then you can also track the pairs. Let me just quickly walk through the other piece of codes which I have written. So you can see that this is the trie node structure which I usually use in all my trie codes, and this is the trie insert. In the trie insert, you will get one string and you will get the integer number for which the string representation is given, and simply I will be inserting it, and at the end, instead of using the word end, I will be using a integer number, and I will be storing the exact number which has been stored. In the search max trie code, you will see the candidate is given. That means this candidate is actually A. So once you have got A, then I am searching for B. How do I do that? So if candidate at I, that is if the current bit is 0, then I will be searching for 1. If the current bit is 1, then I will be searching for 0. This is how I will negate it in the traversal itself, and finally I will return the number, whatever number I end up with. Then in this if else statement, I have also written that if the child pointer exists, then I will go there. If it doesn't exist, then I will take the other option, right? Like if 0 was to be searched but 0's pointer is null, then I will go to 1, right? This is one way of doing the searches. This will just take an integer and what is the number of bits that the integer needs to be converted to a bit representation, and simply this will return the bit string of an integer. So this is the entire piece of code. It will be shared in the description below. You can go there and have a look at it. There is another method of solving this by using simple sets and maps. You can also use that solution, but this is one of the most logical solutions. The code might seem a little long, but if you are good with Trie, then it will look very simple. You can connect me on Instagram and LinkedIn to get more interview tips and tricks. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.